Okay, welcome everyone back to lesson 2 of the 3-part series on simulation modeling for lean process design or mixed model line design. That's the subject. And if you haven't actually seen lesson 1 yet, you might just click on this page. There's a link to that lesson 1 and you can view that first. That'll give you some good background information on what we'll be talking about next. So I suggest you go ahead and do that if you can. And just as a refresher reminder, what we talked about last time was, in the last lesson, was the importance of simulation modeling in the face of variability. And variability in a mixed model environment is pretty much a given. And the kind of variability that is very difficult to understand just in your head or on a spreadsheet include just people variability. Sometimes people work faster or slower, or they're fresher at the beginning of the day, slower at the end of the day. And then you have actual product variability, which in a mixed model line is different products don't have the same work content time. Some are harder, some are easier. All of that has to be considered. And then you have variability in the form of things like feeder lines, options, mix, changes in mix from one day to the next. All kinds of issues that are virtually impossible to really grasp in your head. Sure, if you're experienced enough a designer, you can know what's bitten you in the past and take corrective action, anticipating that you may have some of these problems in the future, but it's not very scientific. And the scientific way to really analyze a value stream or a production line or a process is using some simulation modeling to test for variability. That's the main issue there. Now, why doesn't everyone do this? Well, it's becoming more and more common, but up to now, at least, simulation modeling has been expensive, time-consuming, difficult. Learning curve is steep to really get good at it. Those are some of the issues that have prevented organizations, companies from using this. Of course, it is being used, and larger companies often have simulation departments that specialize in building models, especially for new production lines. That's not unknown. That's very common. But for smaller companies or even individuals, it's been up to now pretty much kind of out of reach. And the learning curve has been steep, as I said, so to really get competent at building models has been a challenge. So that's what we talked about last time. Now in this lesson, we're going to share with you a pretty exciting breakthrough. I'm going to share with you a simulation tool that we use and that you may have a chance to use. And what this allows us to do is build models. What this software tool allows us to do is build models in Excel in a format and an environment that we're already probably pretty comfortable with, and actually use it not for everything in the world, not for every possible scenario, but for the kind of issues we deal with in lean manufacturing, especially in mixed model line design. It's really a perfect fit. In fact, it was designed for those kinds of applications. So part of this lesson, I'm just going to be showing you, taking you on a tour and sharing with you the simulation model based on this example I gave you in lesson 1 with the faucet maker, and show you what I learned and how important it can be to actually take the time and effort to build these models. So you're not going to be watching me, but I'm going to be, in just a minute, I'm going to be switching over to a screen sharing, and we'll take a look at this tool and how you might use simulation model, how you might build the model, first of all, and then how you would use it to actually improve performance. So I think that'll be pretty exciting. Thank you for your feedback on the previous lesson. You have room here on this page to add additional comments, so please feel free to do that. So with that, why don't we just get going? But I need to tell you a little bit of background here as to where this tool came from. When I left my first professional lean consulting company, year 2000, after about 6 years of full-time road warrior in a lot of different companies and countries even, great learning experience, but was not using simulation modeling, I realized that simulation really needed to be part of my toolkit. So I joined a simulation company in San Diego, California, as their quote-unquote lean guy. And I learned that incredibly powerful tool, but also the learning curve issue came in, and at least at that time, and it's probably still true, to really be a master at simulation modeling, you have to dedicate yourself to it pretty much full time. So that was where, when I left them after a couple years and just went into lean consulting full time, that was where we kind of left it. I was a big fan. I can recommend a book actually on this issue called Serious Play, on the use of simulation modeling. And basically the author of this book said the companies in the future that are going to win are going to be those that build models of their processes and then use those models to improve their processes. So I was a big fan at that time. So now we're talking 2002 time frame, but I still didn't have a tool that I could use. So we continued in our lean consulting life. Again, having a chance to work with a lot of different industries and companies, continuing on, but still not being able to incorporate simulation into my toolkit yet. Now, let's roll forward about 10 years from that, 10 years later. So now we're a few years ago, and had a fairly large contract with a big company, a Fortune 100 company, for a line redesign. And they definitely wanted to include simulation modeling. Now, they had their own simulation department, but they were super busy. So they asked me to figure out how to do this. So I went back to my original employer, who I knew were world experts in this, and talked to them about being a part of the team to create the simulation part of this line design. And of course, they said yes. But one of the suggestions from the main guy there, which was now a guy named Jalal Kaplan, was, hey, I'd like to try something out, he said. And of course, the customer would need to agree. But I've been working on an engine, a simulation engine. So discrete event simulation modeling, not Monte Carlo or some kind of other technique, but it's full-blown simulation engine in Visual Basic that would run with Excel. And I think it would be perfect, he said, for this kind of application where you have sequential production lines, workstations, feeder lines. It's really what this was designed for. And the advantage would be just the ease and the speed of development, plus the customer wouldn't need to buy a copy of ProModel or any other software, because it would just be a part of it'd be an add-on essentially to Excel. So I approached the customer. We shared how this was going to work, and they said, okay, sounds good. We're going to save time, save money. It's going to be and we're going to get, presumably, and this is true, the same results that we would get from some of these other software systems, to allow us to analyze our design and improve it as before. So they agreed. We did it. It was successful. We spent days with the team reviewing the model, tweaking it. We actually ended up adding stations where we hadn't originally planned to do so based on the simulation results. So it was a very worthwhile effort. And then, of course, this was all prior to this line being physically implemented, and then it was implemented, and then it came live, etc. So this was a successful implementation. So then I went back to Jalal, the author of this tool, and I said, well, what plans do you have for it? And he said, well, here's my concern. I don't want to start a software company, and I don't want to have to support it, essentially, because I'm busy already, right? I have my clients, I have my business, which is mainly industrial engineering, and I don't want to have to support software. And plus, this tool is not designed to do everything for everyone. So there are commercial software systems out there that people can buy that would be more fully supported and more fully functional, actually. So we said, or I said, oh, okay, that makes sense. I understand perfectly. And we kind of left it there. So here comes the exciting part. About 6 months ago, I approached him again because this was bothering me. Here we had this tool that was pretty easy to use and pretty exciting, that was just sitting idle, right, not being used. So I approached him again and I said, look, what if we put together a class, a workshop, to train people to be essentially super users of simulation, but we also give them this tool with the understanding that it's a teaching tool. It's not a commercial product, so support for it afterwards is going to be limited. It's not that it doesn't work. It's just that it's not a commercial product. And he said, well, if those are the conditions, then I'm open to it. So I said, great, let's proceed down that road and see how far we get. So I'll be sharing with you how far we've gotten in terms of that initial idea. But for the moment, let me just share with you the tool in this lesson and what it will do and how it works. And then we'll talk in a little more detail in lesson 3 about where we might go from here in terms of getting this tool into your hands, for example, wink, wink. So that's the backstory. So at this point, I'm going to kind of sign off, and we're going to switch over to the actual tool itself. So remember, this is all Excel-based, so I'm going to be showing you, and I'll be talking you through the creation of a model, and then using this tool, and then we'll be running it, and then we'll be showing you some of the output and how you could use a tool like this to actually improve a process. So I think this will be pretty exciting. And then I'll come back to you at the end of this lesson with a little wrap up. So with that, let's get going. Let's jump right into what we're calling the Lean Simulator tool based in Excel. Okay, I'm going to take you on a tour of the Lean Simulator. And the first thing I'm going to do is walk you through the data file. Now this tool is divided into 2 Excel files. One is the engine that runs a simulation, the other is a data file. So the nice thing about this, there are 2 nice things. One is you can have a lot of different data files, and you can easily switch from one to the other, so you can maintain lots of scenarios with different data files. And the other thing is you're going to build this model by populating the data, essentially. So you're kind of doing 2 things at once. You're building the model and you're adding the data in the same step, which is kind of unique. So let's share with you the data that we're going to be looking at. This is a very simple model, but keeping it simple so you get the idea of what's involved. So first thing is you have a tab. If you look down here at the bottom, there are various tabs that we're going to be filling out. And the first one is called flow description. So every line and or feeder line requires a code. So if you have a main line, we're calling this line. You can call it whatever you want to. And if you had feeder lines, you'd have to have a designation or a code for each of the feeder lines as well. So that's pretty straightforward, I think. Next tab I'm going to click on is resources. Now in resources, we're talking about the workstations, machines, people, different labor categories that you may want to have in this design. So again, in the interest of keeping this simple, you'll see here that I have 4 workstations. So final assembly workstation 1, 2, 3, and 4. And then I've got operators or workers. Now we could have multiple worker classifications and multiple machines and stations, so on. It can be much more complex than you see here. There's a code to identify what type of resource this is. So we have a production resource or an operator O, and then how many units are processed through this at a time, and what's the overall capacity of this. So you notice here we've defined 4 people, so 4 units. So if I'd had 2 workstation 1s, that would be 2 stations, okay, that would do the same kind of work. And then what's the capacity at each? We're just saying 1 unit at a time, or single piece flow. And then this column F is number of IPKs. So IPK is the term in-process Kanban. It's the term we use for buffers. So you'll notice nothing at the moment, no buffers. So these stations are connected with no inventory in between. Travel time can be entered, return time can be entered, and then variability. We're talking here about the time variability based on human differences. So people work faster, work slower. Right now we're starting this with no variability. And then what data do we want to capture? So report results means do we want to capture data against this resource? Yes or no? We don't have to. And then animation, there's a simple kind of animation built into this, and we can turn that on or off as well. And then this is something you don't need to manage here, but it shows you where this animation is going to be located on the screen. All right, so that's resources. Now, flow is take those resources and tell me how they're connected. So we have this line here, which we defined in the first tab. We've got 4 workstations, but on this row, row 2, we're saying station final 1 is connected to station final 2, and the labor category that works at that station is operator 1. And 100% probability that it's going to go to the next location. So you can see we can have branching here and splitting and add variability of that type. And then, of course, onward and upwards. So station 2 connects to station 3 to 4, station 4 to end. So this hashtag exit hashtag is the indicator in the system that that's the end of the line. So pretty simple, but it can be more complex. We can add feeder lines. We can do a lot of things here, but we're keeping it simple for the moment. Default times are when you don't have a time in the timetable that we're going to see in a minute, then use these times, is what this means. Okay, so let's continue on and let's look at the products. So I've defined a couple products here. And this code is like a part number. So we have high 1, high 2, low 2. And what we mean by this is that we want to test for differences in time. So we have variability in time from an average. So work content of 1 plus 30%, 1 minus 30%, 60%, and so on. So we can play with that. And these products are going to be built on this line, this flow line. Next, process times. So you'll notice here all these times are the same. So what happened to high and low times? Well, we're going to get to that, and I've added another time here. We'll just rename this tab here to be able to use it. But for the moment, I just want to test the model, make sure that everything is connected properly and that it's working correctly by just putting in a time of 1 minute across the board for every product. And then the last thing we need to enter is the sequence. So this is the production schedule. So what I've done here is just simply alternated the products. Complete true mix model form. So we do a high 1 and then a low 1 and then a high 2 and a low 2, high 1, and so on and so forth for quite a few products. So that's all we need actually for the data file. For the simple data file, it can be a lot more complex. Now let's switch over and go to the flow simulator. So the flow simulator, let's see if I can zoom in a little bit so you can see that a little bit better. The flow simulator has a couple buttons here, simulate and validate. And then some pages where we can see the results. So order results and then resource utilization results. And then the engine is included here as well. So let's start with just validate. We click on validate and it says no errors. That's good. That's like something worth clicking on when you make changes. That means everything seems to be connected up correctly. Now, here's the question I want to ask you, and then we'll run the simulation and see if this pans out. If we have 1 minute per unit, once we've wet the line, so that's the warm-up time, we should get 1 unit a minute, correct? Assuming there's no variability, nothing else is going on there, it should be, for every minute that we run the simulation, we should get a unit. So if we set this to 420 minutes, I would expect to get 420 units at the end of that simulation time. So let's test this, and that'll give me an indication that this model is running as expected. So here is station 1, station 2, station 3, station 2. This is a JPEG. So you have a static view of your line design. It could be a CAD drawing that you put in here. And then you're putting these little status symbols or icons onto that JPEG, on top of that JPEG, that are going to, based on this legend, give us a status as the model's running, as to if that station is busy, if it's blocked, if it's waiting, if it's in transport time, etc. So it's going to run pretty fast and without slowing this down. You can slow this simulation down, especially for debugging purposes and really see how things are flowing. But it's going to run, normally it's going to run too fast to really be of too much use other than knowing that it's working. So warm-up time, 5 minutes. That means it's going to run products for 5 minutes and wet the line. So we won't start with empty stations. And then at the end of 5 minutes, it's going to start collecting data and run for 420 minutes based on this schedule we've created. So let's see what happens. I'm just going to click on the Run button, and it's going to load the data from that worksheet, and then it's going to start running. Of course, this doesn't take a whole lot of time. And notice that these status symbols are green. That means there's no waiting, no blockage, no variability, essentially. Everything's flowing just like a freight train and going through the schedule. And in just another second or so, we'll be done, and we'll look at the results. Well, runtime 390, 391. Not as expected. So, let's figure out why that happened. And I think I know why. So this is the kind of process you might have to go through. If I go back to the data file and I scroll down, I might find that I don't have enough products in the data file. And sure enough, that's the case. If I ran out of orders, then of course the simulation is going to stop. So what I'm going to do here, you're seeing me correct this real time. I'm going to add enough orders in here to make sure we're covering at least 420 minutes. So hold with me a minute. I'm going to do that. And then we need to have some warm-up time in there as well, so I'll take a little bit beyond that. Okay, I'm going to save this. Now let's try this again. And this gives you a pretty realistic idea of how this would actually work. And here's another thing I'm going to show you. When you disable the animation, in other words, these won't be updated, this is going to run a lot faster. So watch what happens when I click on Run. It loads the data from that worksheet, and it goes pretty much zoom. It's going to run about 10 times faster, depending on the model, and it's done. And 420. As expected. So what this tells me is that the model is working, but we haven't actually done any real experimentation. So let's get on to that and show you how that would work. Okay, so we've now validated the model, and we think that everything's connected correctly and that it's running. We got the expected 420 units. Now let me show you something that is going to cause you to maybe rethink this. I've changed this variability here from none to high. So I made no other change to the model other than adding a high degree of variability to the times. So what used to be 1 minute across the board is now a range of times, around an average of 1 minute, but sometimes more, sometimes less. That's the only change I've made to this model. So let's save that. Let's go back to the model and let's click on Simulate and let's run and see what impact just normal human variability can have on the throughput in a line that was perfectly balanced and running, at least on paper, exactly the way we wanted. There we go. So we've gone from 420, which we had before, running in 420 minutes, down to 354. So that's a pretty dramatic drop in throughput just from adding variability, normal human variability, which frankly, when you're dealing with humans, is always going to be there. So let's try one more thing then to overcome this kind of variability and improve performance. I'm going back to the data file, and I'm going to add on the same sheet, it's the resources sheet, I'm going to add some buffers. So 1, 2, 3, 4. What this means is that we're allowed, the operator's allowed to have one extra piece at the station, one in the downstream in-process Kanban and one at their workstation. So we're adding the ability to have, not that it's doubling inventory in the line, but we're allowing the existence of one extra piece in the line to hopefully overcome some of this variability. And there's something else I want to point out to you. We've actually sequenced this with a high work content unit followed by a low work content unit. So if I go all the way to the top, you'll see it's a high, then a low, then a high, then low, high, low, high, low, high, low. So this is, the expectation here is that by doing that, we can kind of offset the time differences. Sometimes I'm over at average, sometimes I'm under, and that it might all balance out in the end. So let's see how this affects our model. So we're going back to here. We were originally at 420 with no variability. We added normal variability here, 354, and now we're going to add buffers and run. And here we go. So we're turning the animation off, but you'll notice here it added an icon for these IPKs. So workstation 1 IPK, 2 IPK, 3 IPK. If we were to turn animation on, we'd see those flashing. All right, and we're up to 402. So the lesson here is that, sure, adding IPKs is going to add a lot of benefit to overcoming this variability. Now, one more experiment. I'm going to go back here and I'm going to change this process time, where the times are all the same. I'll call it process time old, I'm going to rename this process time to process time. Let me try that again. And process time. There we go. So it's going to be using this file now where we actually have variation in the work content time. And the other thing I'm going to do is turn these IPKs on the resource tab off. Again, I'm going to take these out. So we have high variability. Well, let's turn the variability off as well. So I'll say none. So the times are going to be as shown here. But let's see what happens to throughput. So here's a line with no buffers and no actual variability. The only variability would be in the work content times that we're seeing here. So sometimes 1.3 minutes, 1.7 minutes, etc. And let's see how that affects performance. Simulate. So 402. So the IPKs, you'll notice, have disappeared here. The data file's being loaded. Or did I click on run? Maybe not. There we go. And we're running the model. And 262. So the lesson here is that if you have variable work time, variable work content in a mixed model line, this can have a huge impact on your throughput. And if your original design was intended to produce 420 units in 420 minutes or per shift, you're way below that now. So you can see, I think you can hope to see now the beauty of using a tool like this to really set buffer sizes, put in a reasonable estimate of the variability you expect to see in terms of work time, the actual standard times for the different products, and actually be able to improve the line. Now, in terms of seeing what actually happened, we can go to resource stats, and we can start seeing then the level of utilization. Percent busy is only 63%, blocked a high percentage of the time. And what we normally do is look for where are the bottlenecks. Apparently in this case they are pretty evenly distributed across the board. But normally we would see certain processes that are causing a constraint, kind of a theory of constraints concept, and we would target those particular resources for some balancing tools. That could be either adding more buffers or adding more resources. It could be that we don't have enough workstations to achieve that volume that we want. So part of your job as a super user is to know how to interpret these results. We have order results, the flow of product through the line during that time period, the 420 minutes, and then we have actual utilization results. And normally we're going to be looking for opportunities to improve that throughput by focusing on the places where that constraint is. Okay, so I think that's enough of a demo. Gives you a taste for this tool, but I think you can also appreciate how basically simple it is to create a model. I mean, it can get complicated, but you enter the data, you run the model, you look at the output, and then you make improvements to the model, and you keep track of your improvements too. And at the end of the day, you're going to end up with a much better design than you would have had if you'd simply implemented a static design based on spreadsheet calculations and then tried to improve it later when you didn't achieve what you wanted to achieve with that design. So with that, I'll leave you and we'll continue on here with this lesson. So that's it, and welcome back, I'm back, and I hope you were excited with this as much as I am, because what I felt, I'm speaking personally here, now I have a tool that I could use for a lot of the types of applications that we deal in without the steep learning curve. It's something that's pretty easy to understand, and there is a manual that goes along with it. So what are we using this tool for? What are its capabilities? I have a list here in front of me of the kinds of things that it can be used for, and we've seen some of those in the last segment. So testing for variability of work time. So this is people-related variability. You saw that setting there, low, medium, high. Also high interdependency. So we can have multiple workstations that are linked sequentially and test for the impact of throughput on that. And as I said before, mixed model line design has inherent variability, so we can test for that. Now, other things we can test for: feeder lines, spurs, options, optional lines. All of these things can be included in this kind of model. Also very important, the use of buffers, or what we're calling in-process kanbans. You saw the use of that in the model, and that's built in. Sequencing. So the schedule that we're using, that we're running in the model, can be an incredibly powerful tool for developing sequencing rules. So trying out different mixes of products. This is an extremely common thing to have to do in a mixed model line. For example, never run product A behind another product A, because we know they're high work content, and it's going to cause the line downstream from those products to dry up, and it's going to be a blockage upstream. So we know that you shouldn't do that. So separate the A's by 10 units or something in the line, and you'll improve your throughput. Typical sequencing rule. Also testing for flexing. So flexing means what happens if I over-design a line, potentially, or maybe demand is down on any given day. I don't need to run it at capacity. And what is the impact of removing people from that line and having people move, which is what we call flexing? What impact does this have on productivity? We expect the volume to go down, but could productivity go up? Chances are good it will, and we can test that in the model. And the last opportunity that I'll mention right now for using these kind of models is Kaizen. So once the line's in place, can we use this as a daily planning tool, or use it to validate improvement ideas before you actually go out and try to implement them by incorporating them into the model? Absolutely. So all kinds of incredibly powerful opportunities for using this. So in lesson 3, the next lesson, we're going to talk about where do we go from here, and how do you get your hands on this tool, but also what are the kind of things that you need to learn and do. So stay tuned for that in lesson 3. I want to recommend a book too that covers a topic. If you're excited enough about this topic to do some self-education, there's a book called Simulation: The Practice of Model Development and Use, and the author is Stuart Robinson. Great book, designed for the super user, not the simulation professional necessarily, but great book to get you started on this whole issue. So we talked about the why in the first lesson. We talked about what is it in this lesson, and in the third lesson we're going to go ahead and talk about how to make this happen for you. And we'll be sharing some really cool stuff as well. And this has never been offered before, so if you're watching this, you're among the first to even hear about this. So congratulations on that. Thank you for your comments. On this page, you can add some more. Just go down there. If you're already on this page right now, you can go ahead and add some comments or questions, and we'll get to them. So with that, I'll let you go, and look forward to an email for lesson 3 in a day or two. Okay, so we'll talk to you again.